In this video, we will talk about Fischer projection formula. What is Fischer projection formula? Where it is used? What is the function of Fischer projection formula in organic chemistry? We will talk about in this lecture. The first scientist who proposed this formula is Emil Fischer. The definition of Fischer projection formula is this: the representation of two-dimensional structure of stereoisomer. It is a representation of two-dimensional structure. What is stereoisomer? Stereoisomer are those compounds which have same molecular formula and structural formula, but different spatial arrangement of atom. But different spatial arrangement of atom. Without destroying the information about the molecule is called Fischer projection formula. To draw a Fischer projection formula, first of all, we draw our two lines. One is vertical line and another is horizontal line. And four functional groups are attached at the corner of each lines. After represent functional group, there are many functional groups which are used in organic chemistry. And the most important points in draw a Fischer projection formula is to representation of vertical line, what shows about horizontal line, and what is intersection, point of intersection, and what is the representation of point of intersection in Fischer projection formula. The vertical line represent the functional group are into the board. It means the functional group are projected into the whiteboard. Yeah, into the page. You move away from you. Yeah, move away from you. And the horizontal line represent the functional group are projected out of the board. It's moved toward you. This is the horizontal line. And the point of intersection where two lines, horizontal line and vertical lines, are made is known as point of intersection. This point of intersection represents the central atom or carbon atom. This point of intersection represents the central atom or carbon atom. First example of Fischer projection formula is lactic acid. First of all, we draw a three-dimensional structure of lactic acid. This is the 3D structure of lactic acid. When we draw a 3D structure of lactic acid, a lot of time is lost during draw a structure, three-dimensional structure. This is a simple structure. When we draw a long structure, then we waste a lot of time. To save our time, science always provide easiness and convenience. For this purpose, we draw a Fischer projection. We simply draw our two lines. One is vertical line and other is horizontal line. Then we write this function group on that line and this that line. These two function groups are right on the horizontal line and these two groups are right on the vertical lines. And this formula is Fischer projection formula. And when we draw a little bit complicated molecule where two carbon are present at the center and there are different function group are attached to the central carbon atom. When we draw this molecule, we lose a lot of time. And when we draw a Fischer projection formula, first of all, we draw a 2 point of intersection. What we draw a 2 point of intersection here. This point of intersection represents the central atom. Here, two central atoms are present. That's why we draw a 2 point of intersection. And then these wedge lines represent the functional group CH3 or methyl group are projected out of the plane. And that's why we write this function group on horizontal line. this function group are represented on horizontal line, and this also represent on horizontal line. This dotted wedge line represent that the function group is projected into the whiteboard, and that's why we write it on the vertical line. And this is a formula of Fischer projection. That is all about Fischer projection formula.